I've added this video in order to cover a few points that sometimes I think get forgotten whenever you're learning this subject. Now I've added in this section here in order to avoid some of the confusion. I could have put it in at the beginning, but I would just added a little bit extra confusion for you, I think. So whenever I talked about a function, say the sine function, I mentioned that we can adjust the amplitude and also the frequency, and we change the frequency as integer multiples of a base frequency. Never mentioned anything about the phase, because we also change the phase of the sine and the cosine functions. So if we wanted to, we could write the Fourier series out in this form here. So it could be a value c0, and it could be the sum from n equals 1 to I of some value cn times just the sine omega nt plus some phase angle phi n. Or we could have written it in terms of the cosine similarly like this here. Now we don't write it in terms of just the sine and just the cosine. We always split it up into both sines and cosine, and we're able to split that up because we can say that if we had some function there, say it was c sine omega t plus phi, well that's exactly the same as writing a times sine omega t plus some value b cos omega t. So rather than writing the Fourier series out in just this form here where we add in a phase angle of phi, we always write it out here, and the phase angle disappears here, so we don't see a phase angle here, but the phase angle really in effect is understood because we've got an addition of the cosine and the sine, so it's equivalent to this here. So you can see that, and we'll see it in the graphical calculator. So if we use the double angle, or the summation formula for a sine, and for sine, we can say that this here can be written as c sine omega t cos phi plus cos omega t sine phi. So whenever we multiply that out, we get our c cos phi sine omega t plus c sine phi cos omega t. Now this c cos phi and the c sine phi, these are just numbers, they're just constants. So we could replace these with just a value of a and a value of b. So you get that a sine omega t plus b cos omega t. So therefore we can say that our c sine omega t plus phi is the same as a sine omega t plus b cos omega t. Now you might be looking at that and saying, okay, so if we could write the Fourier series out in this form or that form, why don't we just write them out in those forms? Well, we don't, because we want to be able to split it into the sine and the cosine. It allows us to introduce the idea of the complex exponential, and that is at the heart of writing out the Fourier series and the Fourier transforms in much simpler manners. So that's the reason why we want to write it in this format here as opposed to this format or this format. Now as an example here, just so you can understand it, I've put it into the graphical calculator as well, and I've did an example. So let's say we had a single function here, 2 sine 2x plus 0.3. Well, according to the summation formula here, that's going to be 2 sine 2x cos 0.3 plus cos 2x sine 0.3. So that's the same as 2 cos of 0.3 times sine 2x plus 2 sine of 0.3 times the cos 2x. And whenever you work out this 2 cos of 0.3, that gives you 1.91. And whenever you write out the 2 sine of 0.3, that gives you 0.59. So our contention then is that this little function here, 2 sine 2x plus 0.3, is exactly the same as 1.91 sine 2x plus 0.59 cos 2x. And you can see here that we've split this function, which has got a variation in amplitude, a variation in the frequency, and a variation in the phase. We split it into two functions here that have got a variation in the amplitude, and it's got a variation here in the frequency, but we don't add in the phase variation at this point here. The phase variation is in effect taken care of by the fact that we already have a sine and a cosine adding together, okay, which will give us this equivalent here with the phase variation in it. Okay, so let's have a wee look at it in the graphical calculator. So you've got access to this little program here, phase shift, which is in the graphical calculator. It's in the resources section. So what we're going to do is we'll look at a sine function, and we'll see the sine function's got an amplitude, a frequency and a phase, and we can see that we can create that by adding up a cosine and a sine with a different amplitude and the frequency. Okay, so let's have a wee look. We'll have our sine function here. So a sine function is written as a sine bx plus c. So a is the amplitude of 2, b is a frequency of 2, and c is a phase shift of 0.3. And this is the function here in red. So what we're saying there is that we can recreate that function using another function here, which will be in black. So that's the function in black here. And this function in black can sit on top of the function in red if we can find a value for the coefficients d and the coefficients f. So that's like our an's and our bn's. So we found out from the maths we did in the last page that that value should be 1.91. Okay, and the other value, in order to make it sit on top, should be 0.59. So if we put in 0.59 for d, 0.59, and there you see that that function sits dead on top of that one there. Okay, so it means that we've shown there just by an example that we can rewrite that function a sine omega t plus phi can be written as a cos omega t plus b sine omega t. So I hope that hasn't added any confusion. It's something I think that tends to be overlooked whenever you're learning this at first, and I was a bit bothered about where exactly to add this video in. If you think it adds a bit more confusion to you, then you just don't need to bother about it, and you can always come back to it at some other point in time. So thank you for listening to the video. I'll get you on the next one. Goodbye.